Hey everyone, this is Mishal Salim, and today we are going to prove on that 1 equals 2, which is actually incorrect. At the end of the video, I will tell you that 1 is not equal to 2. There is a mistake, there is a violation in this proof. So let's see. Okay, first of all, in order to prove 1 equals 2, we have to suppose something. Let's say A equals B. Suppose that A equals B. Okay, now I have to do something. We have to multiply A with both sides. So multiply A both sides and it become like this. We'll also write comments with every step for you to understand easily that what happened in each step. Okay, so in this step, multiply A both sides. Then in the next step it becomes like A times A is A square and A times B is AB. Okay, now in the next step, subtract B square from both sides. Subtract B square from both sides. So okay, so let me write it in a comment as well. That subtract B power 2. I will use this for power. Subtract B power 2 or B square from both sides. Okay, then in the next step, just factorize these two sides. As you can see here, on this side it is A square minus B square. So it is a formula, algebraic formula. We can factorize it through formula, and in the on the right side, this side, we can also factorize this one. So let's factorize it. So A square minus B square is A plus B is A plus B times A minus B. And on this side we have we'll take B as common, as both the terms have B as common factor. So B common, and then there's a mistake. It is not AB square, it is just AB. Now take B as common, and then it becomes A minus B. So I'll also write it in a comment that factorize both sides. Okay, now in the next step, I'm going to divide A minus B on both sides, as both the sides got A minus B as a common factor. So a minus b, a plus b into a minus b, and then divided by a minus b. Then equals b into a minus b over a minus b. Okay, now as you can see, I can cancel these two. There's a minus b with a minus b and a minus b with a minus b. So what are we left with? So on the left side, you're left with a plus b, and on the right side, there is only b. So as we supposed that as a equals b, as a equals b, so I'll use b instead of a because a and b both are equal. So b plus b equals b. Now we just have to add them, add these two, b plus b. B plus b is 2b. Equals b. Now two sides got the same variable, which is b, so I will divide both sides by b, and then these two are cancelled, leaving one behind, and these two are also cancelled, leaving one behind. Okay, so on the left side we got 2, and on the right side we only got 1. So hey, we proved it that 2 equals 1, or we can say 1 equals 2. 1 equals 2. So by the look of it, it seems like we proved it, but we have not. It can't be proved that 1 equals 2. There must be a mistake. There must be a violation of some mathematical rules in this proof. So let's see, where is the violation? Okay, I'll show you. Here in this step, we divided both sides by a minus b. Both sides are divided by a minus b, and we can't divide by a minus b. You know why? Because in the first step we suppose that a equals b. So if a is equal to b and I'm going to subtract b from a, so it will definitely result in 0. It will result in 0, as you can see 1 is equal to 1, and if I subtract 1 from 1, it will result in 0. It will result in 0. Similarly, here in this case, if a is equal to b and I'm going to subtract b from a, it will result in 0. So here actually we are dividing both sides by 0, which is a violation of mathematical rules, because we can't divide by 0. If we divide something by 0, it results in infinity. Let's say I'm dividing 2 by 0. So it has infinite answers. It has many answers. So that's why we say whenever we are dividing something by 0, it results in infinity, this is the symbol for infinity. So it's infinity, and we can't divide something by 0. So here in this step there is violation of mathematical rules. That's why in infinity anything can happen. Anything can happen means that 1 can be equal to 2 or something else can be happened. So we proved it that 1 is not equal to 2 actually, but in infinity it can. Well, that's all. Thank you very much.